I'm very happy to talk about my research, which focuses on AI explainability for novice technology users. So let's begin. So just to give a broad overview of what motivates my research, I'll talk about how AI interventions are permeating various industries in the Global South, and also such as healthcare and education and agriculture, with an aim to empower underserved people, and my work across different projects to make AI explainable for people in diverse contexts. So despite the proliferation of AI interventions throughout these various industries, little work has been done to assess these users' understanding of AI, how they discern its use, and how they perceive its benefits and implications. In the case of community health workers in the Global South, which is the domain that I focus in, many of these users happen to be novice technology users. This is due to their lack of experience using computers and limited experience operating smartphones. Coupled with their low levels of technology literacy, the introduction of AI in frontline healthcare work stands to exacerbate existing biases within AI and create extra work for caregivers, since they will have to learn how to use AI systems, troubleshoot errors, and explain AI decisions to their patients. These challenges could potentially lead to degraded levels of care for local communities if AI tools are integrated without addressing these concerns. So I'll start off by giving a broad overview of AI in the Global South, and then talk about some interventions that are emerging in this domain. And so we see that AI is spreading basically across all over the world, but most of the conversations regarding its implications focused on communities in the Global North, such as the United States and in Europe. However, this lack of attention on the effects and consequences of deploying AI within the world's most poorest and most marginalized communities is concerning, especially in light of growing initiatives and enthusiasm to use AI to solve complex societal problems. This is often characterized as AI for social good. And so, for example, there are a lot of technology companies like Google and Microsoft who have continued to expand their footprint into the Global South by establishing research labs, general offices, and data centers. However, the establishment of local organizations like Wadhwani AI, which is an independent nonprofit institute based in India that develops AI-based solutions for underserved communities, can help ensure that local interests are being prioritized in the development of AI systems. An example of the work I've pictured on the screen includes an AI system to help frontline healthcare workers in rural India identify underweight newborns and to help monitor their growth. So I'll talk more about my domain of community health work. The shortage of qualified medical professionals in many low-income countries has led to the establishment of programs in which community health workers, also known as CHWs, who are usually women, are recruited from local communities. They receive basic medical training and then work to deliver essential healthcare services to communities in hard-to-reach areas in the Global South. Prior work has shown that CHWs are essential in delivering healthcare services, resulting in improved healthcare outcomes. Also, research has shown highlighted CHW's roles in reducing neonatal mortality rates in Bangladesh, and also how they positively change healthcare behaviors in India. Other work examining the broader socio-technical implications of deploying mobile technologies has also shown how these technologies play an important role in the work of CHWs. Overall, these community health workers are very likely to be the target users of AI systems that aim to improve the health of marginalized communities. For example, such interventions include AI-assisted disease prediction and also AI-assisted diagnosis. However, these users possess little experience with technology and also little knowledge about AI, which could potentially threaten how they operate such systems. Despite research highlighting the role of mobile technologies in frontline healthcare work, not much has focused on AI tools that are relevant for CHWs in low-resource contexts. A few projects have created some smartphone-based computer vision applications to enable CHWs to analyze rapid diagnostic tests, such as work by Dell et al. That has monitored CHW usage of essential healthcare commodities, and work by Park et al. That has built and evaluates an app to let CHWs take high-quality images of malaria rapid diagnostic test. Other work by Yadav et al. Has used a Wizard of Oz design to look at how chatbots might be useful for answering mothers and CHWs questions about breastfeeding. My work also introduces the opportunity for explainable AI to improve systems that cater specifically towards novice technology users, such as CHWs. So to provide or go into explainable AI, we see that it can help avoid such pitfalls as the ones that I talked about on the previous screen that are associated with deploying AI with novice technology users. But nearly all of this work, again, has focused on users that live in relatively research-rich settings, such as the US and Europe. And these users arguably have substantially more experience with digital technologies, such as AI. Thus, there's an urgent need to also closely examine the current state of AI, XAI in the Global South, and identify opportunities to make AI systems more explainable for users in these contexts. In recognition of the growing influence of AI and machine learning in people's lives and the problems around many of these systems being black boxes, a growing body of work is focusing on explainable AI. We consider XAI to be the set of machine learning techniques, such as algorithms, toolkits, and frameworks that equip humans involved in the design, development, integration, and use of AI-enabled systems with the ability to comprehend, trust, and manage them. As advances in AI lead researchers and tech companies to develop AI applications that target the health of marginalized communities, it is crucially important to study how do community health workers perceive AI and what are the anticipated benefits and challenges. In this next section, I'll talk about my first major research paper or project, a paper that resulted from this major project, talking about my work with community health workers in India. In my first paper, we present a qualitative study examining AI knowledge and perceptions of community health workers in rural India. This work was presented at CHI, this Conference on Human Factors in Computing in 2021. For this study, we created an exploratory video publication in which a CHW visits a mother and her sick child. The CHW uses an AI-enabled app to scan the baby and diagnose him with pneumonia. To encourage balanced and diverse responses, we created two versions of the video. A positive scenario in which the mother embraces the use of the AI application on her child, and a negative scenario in which the mother is suspicious and distrustful of the AI application. After viewing one of these videos, CHWs participated in a 40-minute semi-structured interview. Although our findings suggest that CHWs didn't have much knowledge of AI at the time, they had a lot of opinions regarding the perceived impact of AI on their workflows, communities, and their livelihoods. However, these low level of AI knowledge is concerning, given that AI applications that target their work are already in active development, and early deployments of technologies in this domain have already reported failures that at best created additional workflow inefficiencies, and at worst, harm the communities that they aim to help. Overall, CHWs agreed broadly that an AI app may be able to accomplish some of their tasks, but it would never completely replace the breadth of activities they perform, including consultations, immunizations, and culturally sensitive discussions on things such as breastfeeding, birth control, and family planning. I believe that this is one of the most important findings from our study, just because from my perspective, I see that a lot of times AI for healthcare solutions, or just like AI in general, is introduced with the idea of replacing human work rather than complementing it. And so it's really important to see that the end users or target users of such systems actually see themselves continuing to be in place or to work in complement to AI. So next, many CHWs felt that having the AI app perform tasks for them would make their work much more efficient, saving both them and their patients valuable time when making decisions about if and when to seek further medical help. Our participants quickly identified that the improved efficiency would be especially useful in rural or remote villages that might be located far away from hospitals or health centers. Additionally, our participants felt that this app could be used for training them and upskilling them in terms of their knowledge about different diseases and infections, and also that it could potentially be used to solve problems far beyond the capabilities shown in the study, such as, for COVID infections, which is very relevant today. So overall, our contribution shows that HCI research should have a deep understanding of local context, but AI technologies present new societal risks and complexities that must be proactively studied before attempting deployment. The concerns raised by our other findings suggest that CHWs may trust the AI's expertise more than their own, perceive AI to be infallible, and ascribe to it more capabilities than it actually possesses. These utopian views can have far-reaching consequences if, for example, CHWs act on incorrect predictions instead of challenging them. Our work highlights opportunities for HCI and AI researchers entrusted in developing AI with communities in the Global South to understand the challenges of developing AI systems that respect diverse communities' cultural and value differences while ensuring both safe and equitable outcomes. Our paper also brought up the need for XAI to cater towards users from non-Western contexts and those with low levels of digital literacy. Within XAI, there's an emerging focus on work to make AI understandable to non-technical users. But again, with all this work primarily done in the Global North, very little is known about the state of XAI in the Global South. To understand the scope of XAI research being done in the Global South, we surveyed literature to identify papers that discuss techniques of XAI applied in the development and evaluation of AI. I presented this work at Compass 2022, which is a conference on competing and sustainable societies. Using the keywords and the criteria outlined on the slide, we utilized the built-in search functions of the ACM Digital Library, Archive, and Google Scholar. Our searches were not limited to any specific time frame and not restricted to any specific venues or proceedings. From our searches, we discovered 16 papers highlighting XAI work across a range of focus areas, venues, and regions within the Global South. The majority of the papers we found focused on technical implementations of AI and are primarily concentrated in fields such as healthcare or government and policy. A significant amount of the papers we found focused on India, which wasn't really surprising given the high concentration of AI development compared to the rest of the Global South. We also found papers across a range of proceedings, including venues such as CHI and Compass, and workshops at premier machine learning conferences such as NeurIPS, ICML, and KDD. So to start discussing our findings, we saw that in terms of the study populations, to develop or analyze XAI tools for applications in the healthcare domain, scholars focused on women sex workers, community health workers, local communities, taxonomists, social media users, and mothers and newborns in Brazil. In education, one paper focused on students and educators in secondary school settings. For misinformation, another paper focused on tweets on sociopolitical events and use in India. And within papers that focused on government and policy issues, populations included were women in India from a range of caste, households in the Philippines and East African countries, and borrowers on a loan request platform. And in retail, one paper focused on product developers and designers in the fashion industry in India. So thinking about if the data was used local to the context, we found that of the 13 papers that focused on technical implementations of XAI, all used data from regions in the Global South. When relevant data was not available, researchers commonly built their own data sets to fill this gap. Such work highlights the additional labor required in generating local data sets that researchers in the Global South and other low resource domains may need to undertake when implementing XAI systems. Overall, human-centered design and HCI4D best practices generally require that researchers engage with intended users to understand their needs before building or deploying new technologies. However, only 3 of the 16 papers engaged with target users. In one case, instead of directly engaging end users, researchers worked with domain experts to design an XAI tool to mitigate the impact of mosquito-borne diseases like malaria, dengue, West Nile, and Zika. Overall, this lack of engagement is concerning, given the generally agreed upon importance of tailoring solutions to local context and communities in HCI and ICTD research. On the good side, the majority, or 13 of the papers in our dataset, use the technical XIM method to develop an ML model or to conduct an analysis on data. We'd consider the paper to be technical if it developed or used an XI algorithm, toolkit, or library. Several researchers incorporated multiple XIM methods into their model development. While more explanations may be useful to help improve model comprehension, the usage of XAI also brings up concerns around the increased computational complexity of AI models and the high computing resources needed to run them. Finally, best known practices in ICTD often call for deploying technologies directly with communities. Only one of the 16 papers in our corpus developed an XII system that was put into practice with real-world users. In this respective deployment, the researchers noted data being a challenge at multiple points in the development lifecycle, again, indicating the extra work needed to employ XII techniques in a real-world setting. The overall lack of deployment seen within our dataset is a bit worrying, but it falls in line with many AI systems not being developed or deployed for real-world use. We also understand that there exists a combination of challenges in the Global South, including infrastructural limitations, a lack of AI practitioners, and a large number of novice technology users that may possibly inhibit the successful integration of such systems. Despite the lack of deployment seen within our dataset, a few papers in our corpus mention future work focused on implementing their respective systems. Such progress towards putting XII systems into practice is an important next step in testing its viability. However, cautious approaches to deployment are needed, especially in the Global South. Overall, we see that making AI explainable can be a viable pathway for making AI more useful in real-world environments and increasing its effective ability to improve pressing social issues. We envision a future of XAI in the Global South that centers humans while acknowledging the specific constraints associated with deploying such systems in regions where access to data, limits to computing infrastructure, and low AI literacy are present. Engaging with communities most likely to benefit from XAI through fieldwork and ethnography, and then using such insights to train AI practitioners on the needs of these users can help align the values of local communities with those of the systems that aim to serve them. While it will take significant effort and collaboration to reach this goal, it is critical that the broader AI and HCI research communities converge on a research agenda that will address existing inequities and actively work to solve them in inclusive, sustainable ways. So to put all the findings from my prior work into practice, we then wanted to know, how do novice technology users engage with existing XII methods? So to answer this question, I developed interactive high-fidelity prototypes in Figma, partially based on the BillyCamp app developed by researchers at UW, University of Washington in the United States, to diagnose neonatal jaundice. And for this project, I actually went to India last month, yes, in July, to conduct fieldwork and examine how ashas in rural India understood such methods. We spent a week in the field, traveling around various sites in Uttar Pradesh, which is in northeastern India, engaging with 30 ashas, which is a name for community health workers in India, and experimenting with different XII methods. To help explain sample outcomes of moderate or severe jaundice, we represented the explanations in a few different formats based on the graphical and tabular representations of Lyme and SHAP, which are very popular XII methods. Lyme trains surrogate models to help explain how the original model arrived at a particular decision, and SHAP is a method that explains individual predictions by measuring how model features contribute to them. The table on the screen illustrates a subset of the designs that we showed to the ashas, our participants in the study. We also continuously iterated on these screens to create new versions as we gained insights from our interviews. Modifications included changes such as changing the colors, reorienting images, and rewording explanation text. In addition, we also had to change the translations of specific words from English to Hindi, just due to there not being a direct translation from some of the mathematical or statistical terms in English to Hindi. And so after completing fieldwork, we're actually still in the process of analyzing our data and synthesizing our findings. And so overall, we anticipate that the study will allow us to characterize the aspects of explainability that are important to novice technology users and when they receive decisions from AI systems. Additionally, and more importantly, we will be in a better position to understand the design elements and socio-technical conditions needed to develop effective XAI tools for such users. Overall, the goal of my dissertation is to study and improve how AI systems can be made explainable for novice technology users situated within low-resource environments throughout the Global South, with a focus on frontline healthcare workers. So, and I'm very grateful to have been able to present my work in this domain and, to continue on impactful projects. And thank you for attending this talk, and I'm happy to take any questions.
Are there any questions from the audience?
I have a question.
Yes.
Yes.
So if you kind of introduce this AI technology to like these healthcare workers and they're using it, how do you, is there a problem where the workers will really just use the AI to reinforce their own opinion? Like they'll look at the baby and they'll think it has pneumonia, the app says it has pneumonia, and it reinforces that. And then if they look at another baby, they don't think it has pneumonia, but the app says it does. Is that a problem where they're not really utilizing the technology to its fullest?
Yeah, so I would say there are a couple of different perspectives that came up in my first study when we showed just the video probes to the ASHAs. And so one of the findings was that a lot of them understood that AI has the capability to fail. And they compare this to different instruments that they use, such as like thermometers or like weight machines. And they said like, oh, like, sometimes our thermometers don't work. So we know that like, the AI won't work all the time. I think they're mostly correlating this to like, if they don't have like good service or if like, the phone dies or something like that. And so I think like that was, also like another important finding from that work. And then in terms of, I would say, in the impact on their respective decision-making, we did see that there is a possibility for them to just to accept whatever the AI outputs or says. And then also, but there are other things that the ASHAs felt that would be useful, that the AI could bring to their work, especially in terms of validating their expertise to their patients, more so like the parents of their patients. And so they said like, this AI would make me seem like I know more about my job, or like I look, since I have like this fancy tool, the parents will respect me or trust me more. And so yeah, there's definitely a bit of a trade-off when it comes to that aspect. And then also tying this into explainable AI, there's been a lot of work coming out recently that shows that even if people are given explanations about a respective system or like AI system or model, they actually still continue to trust, these explanations, even if the system is wrong too. And so there, also need to be ways to ensure that, XAI methods are interpretable to people with various, varying levels of AI knowledge to ensure that they can actually read and interpret these decisions or these explanations. So.
Thank you.
Anyone else?
So SHEP values take a long time to calculate. How does that impact the user experience?
Yeah, so in this case, I'll go back to the screen that I showed. So basically everything was pretty much like just like drawn by me using like an Illustrator app. And so we weren't doing any like specific calculations. Like we didn't train a model for this example. We were just saying like, oh, like in the field, we actually like brought like life-size baby dolls. So they would take a photo and then the app would like process and then output one of these. Well, it would output two decisions, but they would view one of them first and then view a second one. And so these are pretty much like hand coded based on whether we were diagnosing moderate or severe jaundice. But again, going back to just the overall idea of like model complexity, which is something that I hinted at in the presentation, we definitely do see this, as a potential issue or like bottleneck when actually deploying XII tools in the field, just because again, these systems are very likely to be run on smartphones. And it was actually a bit surprising when we were in the field, like basically 90% of the ASHAs had access to pretty, decent smartphones again. And so they weren't like the, like low models. I don't know exactly like the models they were, but they seem to, be running pretty fine. But again, like we do see that if models have to run locally and also to account for different networking issues that may occur, this could potentially slow or delay a diagnosis or explanation of a diagnosis in this case. And so those are things that have to be accounted for. And I know I'm not super familiar, but I know that, the field of tiny ML is also, helping to address this issue. But in terms of like how explainability comes into this, I'm not really sure what's being done in that aspect. So, yeah.
Anyone else have any questions? All right then. I think those are the questions from the audience.
Right.
All right then. Can we all thank Chinasa for joining us today? And then it's lovely to have you, and thanks so much from us. Okay, and good luck for your future.
Thanks so much. Thank you all again. I'm having a good one.
Yeah.